look at angles and radian measure. If I look at an angle, we're going to say that an angle is the union of two rays with a common endpoint. The endpoint is called the vertex, and the rays are called the sides of the angle. We usually name an angle by its vertex. So over here, if I called this vertex, let's say A, we would refer to this as being angle A. Now, when we talk about an angle, you frequently see an angle being in standard position. And when I talk about an angle being in standard position, what I'm doing is I'm placing it in my coordinate plane, and I'm placing that angle in the plane so that the vertex is at the origin and one side is on the positive x-axis. That side on the positive x-axis is called the initial side. The initial side is on the positive x-axis. And then the other side, that could be anywhere in the plane, is called the terminal side. Now, when I look at an angle that's in standard position, the way in which I get to the terminal side determines the sign of the angle. And so if I look at an angle in standard position, if I look at going up to open it, it's considered a positive angle. And if I draw another set of axes and it's put an angle in standard position, so that's my initial side, instead, if I look at that angle opening downward, it's considered a negative angle. Now, a lot of times when people look at angles, they talk about an angle being measured in degrees. And we define 1 degree to be 1 over 360 of a complete rotation. And sometimes we divide that degree into smaller units. The first smaller unit is 1 minute. And we get that 1 degree is equal to 60 minutes. The next smaller unit is 1 second, and we get that 1 minute is equal to 60 seconds. And so when we talk about minutes and seconds, we're talking about small fractions of degrees. Now, angles can be classified by their measure. And when I classify an angle by its measure, I can have a 0 angle. Its measure is 0 degrees, and it would be an angle where the terminal side, was right on top of that initial side. The next would be an acute angle, and an acute angle would have as its measure something between 0 and 90 degrees. So it's over 0 degrees, but less than 90 degrees. Sometimes we see the Greek letter theta. It's a variable that's frequently used for angle measure. And so here, for my acute angle, I'd say 0 degrees is less than theta is less than 90 degrees. Next, we would have a right angle. And I'm sure everybody's familiar with the idea of a right angle. Usually if an angle's right, and we want you to know it's right, there'll be a little square drawn in a corner, and if that were a right angle, its measure would be 90 degrees. Next, I could have an obtuse angle. And with my obtuse angle, it's going to be open wider than a right angle. It's going to have a measure between 90 degrees Sorry about that. I have no idea what just happened. An obtuse angle is going to have a measure between 90 degrees and 180 degrees. And then we have a straight angle. And a straight angle is made up of opposite rays. It actually looks like a straight line, and its measure is 180 degrees. When we look at an angle in standard position, we can also classify an angle by the quadrant of its terminal side. And so when I look at putting an angle in the coordinate plane, we could have, excuse me, a 0 degree angle. If it were on the terminal side or on the positive y-axis, it would be a 90 degree angle. So if I'm in the first quadrant, its measure would be between 0 and 90 degrees. If the terminal and side were instead on the negative x-axis, that would be a 180 degree angle. And so if I'm in the second quadrant, it would have a measure between 90 degrees and 180 degrees. Instead, if my terminal side going around this way were on the negative y-axis, it would be 270 degrees. And so if we're in the third quadrant, it would have as its measure something between 180 degrees and 270 degrees. And as I go back to that positive x-axis, that would be 360 degrees. And if I'm in the fourth quadrant, my angle would have its measure between 270 degrees and 360 degrees. And that would be if I were going around in a positive direction. I can go through and do that same diagram, and this time instead if I go into a negative direction, here my quadrant 4 would be an angle between 0 degrees and negative 90 degrees. If I'm in quadrant 3, going in the opposite direction, it would be an angle whose measure is less than negative 90 degrees, but greater than negative 180 degrees. Likewise, if I were in quadrant 2, it would be between negative 180 degrees and negative 270 degrees. And in that direction, if I end up in the first quadrant, it would be between negative 270 degrees and negative 360 degrees. Now, in addition to looking at angle measures in degrees, we also talk about radian measure. And a radian is defined in a different way. When I talk about radian measure, I look at a circle and I consider the radius of the circle. Now, if I were to measure that radius and then take a tape measure and measure that same type of distance along the arc, this angle in here would have as its measure 1 radian. So that 1 radian is the measure of a central angle in a circle that intercepts an arc whose length equals the radius. So, what does that mean? Let's say, for example, I have a circle with a radius of 2 inches. If I go through and measure off an arc whose length is 2 inches, that angle would be 1 radian. If I add another 2 inches, so that I have an arc whose length is 4 inches, my angle here would be 2 radians. And what happens is if I define S to be the arc length and R to be the radius and theta to be the angle measured in radians, we get that theta is equal to S over R. And so let's look at another example. This time, let's say that I have a circle with radius 4 inches. We want have an arc whose length is 10 inches. We want to find the radian measure of the angle. We want to find the angle in radians. Well, with a question like this, we're going to use that S over R is equal to theta. S is the arc, so that would be 10 inches. R is the radius, so that would be 4 inches. And we get theta is 10 over 4, which would give me 2.5 radians. And once we go through and define a radian in this way, we then want to see what's the relationship, or how do I convert between radians and degrees. And to come up with that conversion factor, I want to consider a full circle. So let me draw a circle. And I'm going to give it an arbitrary radius R. In degrees, we know that that complete rotation is 360 degrees. In radians, we know that it's the arc length over the radius. And if I look at going all the way around the circle, the arc length all the way around would be the circumference. And hopefully everybody remembers that the circumference is equal to 2 pi r, where r is the radius. So that gives me my angle all the way around is 2 pi r divided by r, which gives me 2 pi radians. So we get that 360 degrees is equal to 2 pi radians. And dividing both sides by 2, we get that 180 degrees is equal to pi radians. And that relationship is what I use to convert. I'm going to take a degree measure of an angle, and if I multiply it by pi over 180, that would give me the radian measure of that angle. And likewise, if I have the radian measure of an angle, and if I multiply by 180 degrees over pi, that would give me the degree measure of the angle. So let's say, for example, I have 90 degrees is equal to blank radians. Well, I'm going to take my 90 degrees and I'm going to multiply it by pi over 180. I want the degrees to be along the diagonal so I can think of the degree symbols canceling out. That gives me 90 pi over 180, which would reduce to pi over 2. Instead, if I have, let's say, negative 135 degrees, and I want to think of it as radians, I'm going to take that negative 135, and again, I'm going to multiply it by pi over 180, which will give me 135 pi over 180, which would reduce, I'm sorry, I lost my negative sign, which would reduce to negative 3 pi over 4. Now, instead, if I have pi over 5 radians, and I want it in degrees, this time I'm going to take my pi over 5 and multiply it by 180 degrees over pi. The pi's would cancel, so I'd be left with 180 degrees divided by 5, which would be 36 degrees. And let's say I have negative 11 pi over 6 radians, and I want to write that one in degrees. I'm going to take negative 11 pi over 6 and multiply it by 180 over pi. The pi's would cancel, so I'll have negative 11 times 180 divided by 6, which would give me negative 330 degrees. Now the first two that we did converting into radians, we left in terms of pi. Instead, let's say I have 60 degrees and I want to turn it into radians, but this time I want to round to the nearest hundredth. Well, I'm starting with degrees, so I'm going to multiply by pi over 180. So that's going to give me 60 pi over 180, which would reduce to pi over 3. And now to round, I'm going to use the pi key on my calculator. And so if I take my calculator and take pi divided by 3, I get 1.05 radians once I round. Now, sometimes we're asked to locate angles and first let's look at it in degrees. A lot of times when you see questions like this, they're done in the coordinate plane with a circle centered at the origin. We've already said that this would be 0 degrees, this would be 90 degrees, this would be 180 degrees, this would be 270 degrees. First, let's go through and let's divide the circle up like a clock into 12 markings. In order to do that, I would be taking my 90 degrees and dividing it into thirds, making this 30 degrees, and then I'll move over 30 degrees each time. 60, 90, plus 30 would be 120, plus 30 would be 150, plus 30 is 180, and then adding 30 I get 210, 240, 270, 300, 330, and I'd be back to my 360 degrees. In addition to those divisions, dividing it up like a clock, we can also think of just taking each quadrant and splitting it in half. And if I think of splitting it in half, half of 90 degrees would be 45 degrees. And so every time I move over half a quadrant, it would be 45 degrees. 45 plus 45 is 90, plus 45 is 135, plus 45 is 180, plus 45 is 225, plus 45 is 270, plus 45 is 315 degrees. Plus 45 takes me to that 360. We should also be able to do the same type of work in radian measure. And so if I look at that in radians, then I make that same diagram. X-axis, y-axis, circle centered at the origin. This would be 0 radians. We had said that 180 degrees is like pi radians. Going all the way around full circle is 2 pi. So halfway to pi would be pi divided by 2. So that's a half. Plus a half is 1 pi. Plus a half, 1.5 pi. We'll write as an improper fraction 3 pi over 2. Now, if I look at taking the whole circle and dividing it up into 12 equal regions, I'd be taking that top half and dividing it up into 6. So this would give me pi over 6. And so when I add 1/6 plus 1/6, I'd get 2 pi over 6, which would reduce to pi over 3. 3/6 would be a half. 4/6 would be reduced to 2/3. I'd have 5 pi over 6. 6/6 is 1. Then I'd have 7 pi over 6. 8 over 6 would reduce to 4/3. 9 over 6 is 3/2. 10 over 6 is 5/3. 11 over 6 would be the next. And then 12 over 6 would be my 2 pi. Now again, after dividing it into 6, we want to just think of splitting each quadrant in half. And so if I think of taking a half and dividing it by 2, I get pi over 4, 1/4, 2/4. This would be 3 pi over 4, 4/4. This one would be 5 pi over 4, 6/4. This one would be 7 pi over 4. And so those are the things that you're asked to consider in that radian assignment. And one last thing that's in there is the idea of coterminal angles. And so let's draw an angle in standard position. And let's say my angle, well, let's draw it someplace else because the paper and I are not friends. Let's draw an angle in standard position. And let's say we're opening upward. And let's say my angle measures in this direction 120 degrees. Well, if I worked backwards, that angle could also be 240 degrees. But is there anything that says that I didn't start here on the x-axis, go all the way around, which would be 360, and then adding another 120 would make that angle 480 degrees. And there's nothing that says that I didn't start here and instead go all the way around backwards, which would be negative 360, and then go another negative 240, which would make my angle negative 600 degrees. And all those measures would look like the same angle. They're called coterminal angles. because they have the same terminal side. And what we notice is the measures differ by 360 degrees, or if we're in radians, 2 pi radians. And so to find coterminal angles, we can add and subtract 360 degrees to degree measures, or we can add and subtract 2 pi to radian measures. So, for example, I might be asked to find the least positive coterminal angle to 735 degrees. Well, I want the smallest positive, so we're going to subtract 360 degrees, and doing that subtraction leaves me with 375 degrees. Since it's still larger than 360, we're going to subtract another 360. And so if I take 375 degrees and subtract my 360 degrees, that would be coterminal with 15 degrees. Instead, if I want the smallest positive coterminal angle, and this time I start with something like negative 630 degrees for the least positive. This time, because we're starting with a negative angle, we'll add 360 degrees. So when I take that negative 630 and add 360, I get negative 270. Because it's still negative, I'm going to add another positive 360, and doing that, I get my final answer to be 90 degrees. If I were to do that same type of work in radian measure, I'm going to try to find first the least positive angle, coterminal, with, let's say, 17 pi over 6. First of all, does everybody realize that 17 divided by 6 is bigger than 2? So we're going to subtract, not 360 degrees, but 2 pi radians. So when I take 17 pi over 6 minus 2 pi, think of the need for common denominators. That would be 17 pi over 6 minus 12 pi over 6, which leaves me with the answer of 5 pi over 6. And instead, if I want the least positive coterminal angle in radian measure, and I start with a negative angle, let's say I have negative 7 pi over 4. Because it's negative, we're going to add 2 pi. And so when I take negative 7 pi over 4 plus 2 pi. Again, getting a common denominator, that would be adding 8 pi over 4. And so my final answer would be pi over 4.